Okay, so this is a six-part discussion in which we'll be covering the whole concept of hypothesis testing. So the first part will be, as stated here, this is the introductory part in which we'll be covering the concepts on hypothesis testing. So the succeeding parts will be on the quantitative portion in which we will now be applying the different statistical tests for us to do hypothesis testing. So for our learning objectives, at the end of this six-part series, my expectation is that for you, being students, to know the definition of hypothesis and for you to be able to differentiate null hypothesis from alternative hypothesis and directional hypothesis from non-directional hypothesis. And also at the end of this six-part series, I am expecting that you students would know how to apply or how to properly do your testing of hypothesis, in which for this discussion we will just focus on the tests or the evaluation of significant differences. So technically we will not touch the uh, evaluation of significant relationship or your correlational statistics, because again our focus will just be the evaluation of significant differences, in which we will be covering your t-test, z-test, and even chi-square. And at the end of this uh, discussion or six-part series of discussion, I'm expecting that uh, you will know how to apply the appropriate test statistics in a given problem. Okay. Now, without further ado, let's start with the definition of hypothesis. When we speak of hypothesis, it's a proposition or it's a claim, okay, or it's a uh, theory, for example, which is placed under examination. So this claim, this proposition is not yet considered to be true, okay, up unless there's already a statistical test being done to it, okay, or you're done with let's say applying statistical test for you to validate whether that proposition, that claim is true or not. Okay, now an example of hypothesis can be, let's say, if you are studying the relationship between, let's say, aesthetics of the the product, for example its color, its shape, okay, and its influence to the purchase intent of the consumer. Okay, so let's say your claim is that if the product is more colorful, then buyers will or consumers will be more influenced to purchase it. Okay, for it will be, or the effect of a vibrant color of product will be the motivation of buyers to purchase that will be more. Okay, so let's say that's the hypothesis. So again, that statement, that claim is not yet true. Why? Because um, we still need to do the proper, okay, or the appropriate test statistics for us to prove that that particular claim, that particular proposition is true. That's why for this discussion, we will be focusing on the different test statistics for us to prove whether the hypothesis is correct or not. Okay, and hypothesis testing is actually a topic under statistics, and it's very relevant in research because um, it actually uh, covers or answers the SOPs on, let's say, significant differences, significant relationships. Okay, or to simply put, your hypothesis testing is being applied in research in terms of the treatment of the data. Okay, for you to uh, extract the answers from the data that you have collected. Okay, the answers to your SOPs or statement of the problem. And when you speak of hypothesis, we have two classifications. So you have your null and your alternative hypothesis or your research hypothesis. When you speak of null hypothesis, it's a type of hypothesis that expresses objectivity or neutrality. Okay, so to simply put, it expresses the idea of no existence of relationship or difference, okay, between the variables that you are studying. So going back to our example, you are trying to prove that aesthetics, the color, the shape of the product, greatly influence the purchase and intent of consumers. Okay, so um, in terms of null hypothesis, because again, it states that or this particular type of hypothesis expresses objectivity or neutrality, then when you speak of null hypothesis, it will indicate that there is no relationship between aesthetics and purchase intent of the buyer. Okay? And when you speak of your alternative hypothesis or your research hypothesis, this is actually the opposite of your null hypothesis. Okay? So in here, you have neutrality, you have objectivity. Now for research hypothesis, it will now state the existence of difference or relationship. Okay, or to simply put, this is actually your research hypothesis. This is what you are trying to prove. Okay, null hypothesis is uh, considered to be the norm. Okay, and uh, if you will, let's say, challenge the norm or what is already established, then the statement that you will use for you to challenge what's already considered to be normal is your alternative hypothesis. Okay, so that's actually the connection between these two. That's the difference between these two. And here are examples of null hypothesis. So, for example, there's no significant difference between the mathematical achievement of engineering students and architecture students. Okay, so in here, it's clear that there's a word no. Okay, so there's no difference between these two types or between these two groups of students, in which, if we will go back to our previous slide, it expresses neutrality. Okay, it expresses objectivity. Okay, so it does not say that engineering students have, let's say, higher mathematical achievement over architecture students or vice versa. Okay, that's why it's considered to be a null hypothesis because it does not really state that one variable has a more positive characteristic over the other variable. Okay, so another example. So here, there's no significant relationship between attitude of students towards their subject and their performance. And then another one, there's no significant difference between the competencies of nurses from public and private hospitals. Okay, so that's or these are examples of null hypothesis. And let's now try to look at the examples of alternative hypothesis. So going back to our previous discussions or previous slides rather, we have stated that alternative hypothesis tends to um, contradict, okay, your null hypothesis. So in here, if you will construct your alternative hypothesis coming from these three, or if you will construct your alternative hypothesis rather coming from these three null hypotheses, then we can just state that there is a significance. Okay? So meaning there is a difference between the mathematical achievement of engineering students and architecture students. So it now implies that one group of students is, let's say, better or has a more positive attribute over the other group of students. Okay, so another one, there is a significant relationship between the attitude of students towards their subject and the performance rating at the end of the semester. And last, so there is a significant difference between the competencies of nurses coming from government hospitals and private hospitals, in which it implies that between these two groups of nurses, one is above the other. Okay? So one is above the other. So these are examples of your alternative hypothesis. And as stated during the first part of or first few slides of this uh, introductory discussion, we will differentiate your directional and non-directional hypothesis. So when we speak of your directional hypothesis, the direction of the difference is clearly stated, okay, in which you will now see that there are comparative words. Okay, so for example, A is greater than B or B is greater than A. Okay, in which uh, the difference between the two variables can easily be seen because or can yes, so the difference between these two variables can easily this can be easily distinguished because there are comparative words. Okay, but for non-directional hypothesis, it's where uh, the hypothesis states that there's a difference between the variables, but it does not state whether which variable has a more positive characteristics over the other. Okay, so examples of which, if we will go back here, so here, there is a significant difference between the mathematical achievement of engineering students and architecture students. So for this particular hypothesis, this is considered to be non-directional. Why? Because um, it does not state whether engineering students have more mathematical achievement over architecture or architecture students have more mathematical achievements over engineering students. Okay? Or let's look at number 3. It states that there is a significant difference between the competencies of nurses from government hospitals and your private hospitals. So it just states that, or this particular statement only states that there's a difference, but it does not show to us whether uh, nurses from government hospitals have more competencies than nurses coming from private hospitals or the other way around. Okay, so it just states that there's a difference, but we don't know the difference. That's why it's considered to be non-directional. Okay, so if we will be having an example of directional hypothesis, then let's use item number 3. We can state that um, nurses from government hospitals have more competencies than nurses coming from private hospitals, in which we can now see that uh, nurses from government hospitals have a more positive characteristics over uh, with that of your nurses coming from private hospitals. Okay, so in which that will now become a directional hypothesis. Okay, so please bear this in mind. So again, directional, we don't know the difference, or there's a difference, but it's not, or for directional hypothesis rather, there's a difference in which it's clearly stated. Okay? And for non-directional hypothesis, there is a difference, but the difference is not clearly stated. Okay? So another example would be, um, let's say the academic performance of students coming from uh, course A and course B. Okay, so let's say for directional hypothesis, we can state that uh, students from course A are brighter than students from course B. Okay, so that's directional. Or if we will state it in a non-directional manner, then we can simply say that there is a difference between the intelligence of students from course A or coming from course A and from those who are from course B. Okay, so that's non-directional. So what's the relevance of this in testing hypothesis? When we speak of a directional hypothesis, it will entail one-tailed test. Okay, and then for non-directional hypothesis, you will now be using two-tailed test. Okay, and please take note, your directional and non-directional hypothesis will be seen through your alternative hypothesis. So I'll repeat, for you to assess whether you will be using one-tailed or two-tailed test, you will look at your alternative hypothesis. You will assess your alternative hypothesis, whether it is a directional or non-directional hypothesis. Okay, so that's the definition of your directional and non-directional. We'll be applying it on the succeeding recorded discussions when we will now be computing for the values, okay, for you to somewhat reinforce your understanding on your directional and non-directional, and together with your one-tailed and two-tailed test. Okay, and so again, here are examples as stated a while back. Okay, so there is a significant difference between mathematical achievements of engineering students and architecture students. So again, this is a non-directional because it simply states that there's a difference, but we don't know which over which is higher or better. Okay, and this is your uh, again, this is non-directional, this is your directional, because you now have your comparative word. Okay, greater than, okay, or better, more intelligent, okay, or brighter. Okay, so those are actually your cues, okay, for you to know whether it's a directional or non-directional. Okay, so the simplest way is for you to look for those comparative words. Okay, so if there's a comparative word on your alternative hypothesis, then it's already a directional hypothesis. Okay, so there. And in terms of testing the hypothesis, okay, so um, based on our previous slide, we have stated that we have two types of hypothesis. So we have your null and alternative. So in testing or in hypothesis testing, your objective is for you to compute, okay, and for you to determine which hypothesis is correct, whether it's null or alternative. Okay, so in which with this of your test statistics, you will accept one between those two types of hypotheses and you will reject the other one. Okay, so that's the goal in terms of your hypothesis testing. So how are we going to do that? How are we going to assess what hypothesis are we going to accept, what hypothesis are we going to reject? Then we will follow these 7 steps. So first, If you have the problem, the first thing that you need to do is for you to establish or formulate your null and alternative hypothesis. Because again, if you don't have your null and alternative hypothesis, then uh, there will be no or there will be no claims that uh, you will be testing. Okay, that you will be trying to prove. Okay, whether it's correct or not. That's why the first step is that for you to formulate first your null and alternative hypothesis. Second will be you will now set the level of significance or your alpha level, in which when we speak of level of significance, the definition is this. Okay, so it's the size of risk of erroneously rejecting your null hypothesis. Again, so HO is your null hypothesis, okay, that the researcher is willing to make. And the common choices for level of significance are as follows. You have 0.01, 0.05, and 0.10. Okay, or 1%, 5%, and 10%. Okay, so what's the relevance of this significant or level of significance? Okay, so um, for the level of significance, the higher the level of significance, then the higher the risk, okay, of erroneously rejecting your null hypothesis. Okay, so the lower, then we can state in a manner that uh, you are somewhat more accurate, okay, in terms of uh, let's say proving your hypothesis. Okay, so in terms of the application pala, normally for level of significance, we use your 1% level of significance for the medical field. Okay, so for example, if you are testing, let's say, a vaccine, okay, so as much as possible, you need to have um, a low amount of margin of error. Okay, that's why your level of significance will be lower. Okay, for you to have a higher confidence level. Okay, so there. And the third step is you will now determine what type of test statistics are you going to use. Okay, so in here we have here the different criteria. You will use z-test if either of the two is present. Okay, so first, if the population standard deviation is known or assumed, or your sample size is greater than 30. So if that's the case, you will use z-test. Okay, so I'll repeat. If the standard deviation comes from the population, or the sample size is greater than 30 or equal to 30, then you will use z-test. Okay, so next, for t-test, if the sample size is small, okay, so if it's less than 30, and if the standard deviation is estimated from sample, not population, okay, then you will be using t-test. And then the assumption here is that the probability distribution of the the random variables are considered to be normal, or to simply put, there's normal distribution of variables. Okay, so if there's normal distribution, and if the sample size is below 30 plus the standard deviation is estimated from the sample, then you'll be using t-test. Okay, third one, you have your chi-square. For chi-square, you will be using it for you to make inferences about the variances and standard deviation of a single population. Okay, and also we'll be using chi-square test if we are trying to check the independence of variables, or we will try to check the differences or significant differences between two or more proportions or percentages. Okay, so please take note. Let's have a review. Z-test if sample size is greater than or equal to 30 and population standard deviation is present. T-test, sample size is less than 30 and standard deviation comes from sample, not population. And the distribution is considered to be normal. Okay, distribution of the variable. And for chi-square test, you will be using it if you will test the independence of variables and if the given is in the form of proportion or percentages, or if you will uh, check or test the differences between two or more proportions. Okay, so after that, the next step will be um, upon, let's say, upon formulating your hypothesis, your null and alternative hypothesis, you will proceed to your significance level. So upon identifying your level of significance, then you will now determine what type of test you are going to use. So after determining the type of test that you will be using, the next step is for you to identify the critical or tabular value. Okay? Critical or tabular value. And uh, please take note of this. For t-test, you need to compute for the degree of freedom first. Okay, so for one sample, you have degree of freedom, it's number of items minus 1. If you have two sample mean or two samples, then you need to add the number of both samples and then you subtract 2 for you to get the degree of freedom. So don't worry, we'll be having an example of this particular step when we proceed towards the computations. Okay, but again, the summary is that for number 4 or step 4, you need to identify your tabular value. That's your main goal. Okay, and then number 5, you will now compute. Okay, you will identify your computed value using the statistical test that you have identified. Okay, the statistical test that you will be using. And then step 6, you will now compare these two values. Okay, so this is now the test for significance. So as I've stated a while back, in statistics, for you to prove your claim, for you to prove your hypothesis, there should be a significant, or there should be a presence of significance, okay, in your values. So in here, for us to test whether your values are significant or not, then you will compare your tabular or your critical value and your computed value. Okay, so here are your guidelines. If computed value is less than tabular value, then your answer is not significant. So meaning your research hypothesis, your alternative hypothesis will be rejected. Okay? And then you will now accept your null hypothesis. Okay? But if it's the other way around, let's say your computed value, the value that you have computed from step 5, let's say if it is greater than your tabular value, the value that you have determined in step 4, then we can say that there's a significant difference between, let's say, these two values, okay, in which you will now reject your null hypothesis and you will accept your research or your alternative hypothesis. Okay, so please take note on that. If computed value is less than tabular value, you accept null. But if computed value is greater than tabular value, you accept alternative hypothesis. Okay? And then the last part will be the interpretation of the result. So for the interpretation of the result, you will just state what hypothesis was accepted. Okay? So there. So that's the end of the first part. So for the second part, we'll now be discussing the quantitative approaches. Okay, or we will now be covering the discussions on your statistical tests.